All right, so here's where I left off with the third example. I did forget to put the parentheses around this -3 because -3 to the fourth and -3 to the fourth are not the same thing. So just be careful with that. But the answer either way is 1 over 81. So lastly, let's look at this example, and then we'll get into solving equations. This is -25 to the 3/2. Just keep in mind this negative. Basically, I'm going to go through this whole thing, and then I'm going to make the answer negative. That's what this negative tells me. So this is -25 to 3/2. Tells me I'm taking the square root of 25, and I'm raising all of that to the third power. So this becomes the square root of 25 is 5 to the third. So it's -5 to the third is 125. So the answer is -125. That's the last of those examples. We're moving on now to solving equations. So now we're going to look at solving equations using nth roots. This is, again, is pretty quick. So if you want to pause and work out your own examples, you can. We're going to solve these just like we would solve normal linear equations or quadratic equations, following the order of operations. So the first thing I'm going to do here is get this x squared by itself. I'm going to divide both sides by 2. So I would get x squared equals 18. And now I'm going to take the square root of both sides. So this is something you have done before. This isn't new. I'm just showing you that the same process still stays. So the square root of x squared is x, and this equals plus or minus the square root of 18, which can be simplified. So this becomes plus or minus the square root of 9 times the square root of 2. So x equals plus or minus 3 square root of 2. This is something we have done before. We're going to continue this same concept over into the next example. So the next example, I don't have to divide by anything because I already have this quantity by itself, but I want to get rid of this fourth power. Well, to get rid of a square, we took the square root. Well, to get rid of the fourth, we're going to do the same process. It's just now we're taking the fourth root. So I'm taking the fourth root of this quantity to the fourth. That's just going to give me the quantity, x minus 4. And I'm taking the fourth root of 81. So what number times itself 4 times gives you 81? Well, that is 3. 3 times 3 times 3 times 3 will give you 81. But that, keep in mind, that's plus or minus 3. I still have the plus or minus because it's an even root. All even roots will have the plus or minus. So this becomes x equals, if I add 4 to both sides, 4 plus or minus 3. So I have my solutions as x equals 4 plus 3, which is 7, and x equals 4 minus 3, which is 1. And a couple more examples. Same process. We have x minus 3 quantity to the third equals 54. So here again, I want to get rid of this third power. I'm going to get this x minus 3 by itself. So I'm going to take the cubed root of both sides. So this is going to give me x minus 3 equals the cubed root of 54. So the cube root of 54 might not look like it can simplify. But just like simplifying square roots with radicals, we look for two perfect squares. I'm sorry, not two perfect squares. We look for a perfect square factor. We look for a factor of 54 this time. That's a perfect cube. And if you forget what your perfect cubes are, you only really know the first 5. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 81, and 5 cubed is 125. Those are really the only 5 you need to remember, because after that it starts to get, really big really fast, and it'll be obvious what the cubes are. So I'm looking for a factor of 54 that's a perfect cube. Well, after a little bit of reasoning here, I get x equals the cube root of 27 is a factor, and I multiply 27 times 2 to give me 54. So I'm going to move this 3 over and get x equals 3 plus the cube root of 27 is 3, cube root of 2. And then last example, we have negative x to the 5th equals 96. So the first thing we have to do is get this x to the 5th by itself. It looks like it's by itself. What I'm going to have to do is divide both sides by -1. When I do that, I get an x to the 5th, positive x to the 5th equals negative 96. And don't automatically assume that because we're taking roots, we can't do negatives, because negative roots are not imaginary numbers. Negative odd roots are not imaginary numbers. Only negative even roots are imaginary numbers. So here I'm going to take the 5th root of both sides. And I'm going to get the 5th root of x to the 5th, which is just x, equals the 5th root of negative 96. Now, you might not see the factors of 96, how this is going to break up, but I want to look for perfect fifths that are factors of 96. You don't have to know these, but just kind of the first real quick. I mean, it's always 1. 1 to the 5th is 1. 2 to the 5th is 32. The question is 32 a factor? Because the next one is 3 to the 5th, which is like 200 and something. I don't even know what that is. So I'll worry about 32. 32 is a factor of 96. 32 times 3 gives you 96. So this can break up into the 5th root of negative 96 and the 5th root of 3. And if you don't believe me, 32 times, wait, I messed this up on. Sorry, not the 5th root of 96, the 5th root of 32. 32 times 3 gives you 96, and 32 is a perfect cube, or perfect fifth, I'm sorry, because 2 times itself 5 times gives you 32. So this becomes x equals the 5th root of negative 32 is negative 2, and then I have the 5th root of 3. So x equals negative 2 times the 5th root of 3. And that is all for the chapter 7.1. If you have any questions, please write those down, and I'll answer them in class.